This document, basically, we have 5 sections that we're supposed to handle today. So we have the introduction and then joining pieces together. Um, Basically, yeah, I think it's like basically we're trying to bring in the data that we need. We are bringing them together so that we can perform some analysis. And then the next section is the last analysis, finding the final insights from our data. So after joining in the tables or bringing data, pulling data from different tables, you perform some analysis, and then you also have summary report, uh, which basically involves sharing knowledge with decision makers, and then we have a practical plan. So from the analysis and then the reports, you'll be able to formulate a plan. So I don't think I'll be going to the introduction. So let's summarize the data we need and where to find it. All of the information about the location of a water source is in the location table, specifically the town and the province of that water source. So I believe we are all aware about that. And then water source has the type of source and the number of people served by each source. Visits has key information and connects source ID to location ID. There are multiple visits to sites, so we need to be careful uh, to include duplicate data. So that is where visit count is greater than one. Well pollution has information about the quality of water from only wells, so we need to keep that in mind when we join this table. Mm. Things that spring to mind for me, are there any specific provinces or towns where some sources are more abundant? Number two, identify that tapping home broken taps are easy wins. Are there any towns where this is a particular problem? So to answer question one, we will need province name and town name from the location table. We also need to know type of water source and number of people served from the water source table. The problem is that the location table uses location ID. Uh, so take note of this. Location table uses location ID. So location ID is like the primary key in the locations table, while water source only has source ID. So we want to be able to join these tables directly. Okay. But the visits table maps location ID and source ID. So if we use visits as the table we query from, we can join location where the location ID matches and water source where the source ID matches. So basically, what is happening here is, of course, we need to join these two tables for us to be able to uh, answer question one here. So we have the location table and then we also have the water source table. There is no um, uh, common column that you can use to connect these two tables. That is the location and water source table. Um, because in the locations table, we have the location ID key, but location ID is not present in the water source. Instead, we have the source ID in the water source table. So there's no way in which you can connect the two tables directly. So that's why if you want to connect these two tables, you have to go through the visits table, because visits table maps location ID and then it also maps source ID, right? So this is another way of connecting tables, indirect way of connecting tables. So we need to connect that, but before we can analyze, we need to assemble data into a table first. It's quite complex, but once we are done, the analysis is much simpler. So start by joining location and visit. So you need to join these two tables. You should have the following columns. So by joining, okay, the main aim is to join locations table to the water source table. But since we cannot join them directly, we have to join them through the visits table. So the first join is basically we are joining the locations table to the visits table. And then from the visits table, we are going to include also now, we are going to join the water source table as well. So this is the first join you're supposed to do, locations to visits. And then you basically come up with something like this. So you'll come up with a table that has province and town names, visit count, and location ID. And then after that, now we can join the water source table on the key shared between water source and visits. So you see, after performing the first join, which is basically location and visits, now you proceed to the second join, which will now be allow you to include water source table as well using the source ID. So basically, this is the final table you should have after performing the two joins. So I think, okay, let's see. Not that there. Okay, let's perform the joins first, and then we can proceed. So, so let's use it's MD water services. So that's the database we are using. And then after that, now we want to join the following tables. We want to join location uh, to water source, right? But for us to perform this join, we've seen that we need to pass through visits table, right? Because there's no way in which you can connect the tables directly. So we are going to do the first join where we join location to the visits table, right? And then after that, now we move to the water source table. So our first join, let me confirm the columns that you're supposed to come up with. So we need province name. We also need town name, visit count, and location ID. I think visit count is in the visits table, right? Town name and province name are in the location table, if I'm not wrong. Let's just confirm. Uh, So where's the visit? So this is the visits. So visits, when you check the columns, we have the visit count column, and we also have location ID. Location ID is a foreign key in the visits table. It's what we are going to use to connect locations table to the visits table. On the other hand, where's the visits table? Oh, I mean, locations table, not visits. Yeah, it's location. So location table, we have the province name, town name, we also have location ID, right? So let's write the query. So we are basically going to select, they want us to take province name. They also want us to take town name. They also want us to have the visit counts. And the last one was location ID, right? So these are the columns that we want. Okay, so what we can do is, because location, province name, town name are coming from locations table, we have to uh, add location dot this. But I think what we can do, let's just use aliases. So when you say L dot province name, we are going to alias locations table to this letter L. Okay. So let's continue writing the query. I'm going to show you where that is going to come in. So we have that, and then visit count is in the visits table. So we have V like that, and then we also have L dot location ID. So this we can say from location as L. So this is the L we're using here, right? Basically, um, it can be tiresome typing the word location. So you give it another name that is short and easy to type. In this case, we've given it the name L, right? So we are getting, first we are querying the locations table to get those columns. And then after that, uh, now we join, is it visit or it's visits. So we join visits as V. So let's give it also an alias because we've used it here, v.visit count. So we join uh, visits on. So we specify the column you're using for joining. So we're using l.location ID equals v.location ID like this. So this should give us that table that has the province name, town name, visit count, and location ID, right? Now I believe you guys have read something on joining tables. We have join, yeah, inner join, left join, right join, and all those other joins. So when you just write join like this, it's the same as writing inner join, right? So it's not a must you specify it's an inner join. If you want to perform a left join, of course, you have to specify this is a left join. So here it has to be left join, or if it's a right join, then you have to specify. But for inner join, it can just be join. So let's run this query. So when you run the query, this is what you get. So we have the province name, we have town name, we have visit count and location ID. So this is the first join we have done, right?
Lord Eve is raising her hand.
Mm-hmm.
Eve, you can talk.
Okay, hi.
Hi,
Hey,
how are
my
you?
question, I'm doing good, thank you. So my question is like, can you use notebook instead of MySQL Workbench? I mean, can both of them do the same thing?
Yes, yes,
Because
yes.
when I was trying to go through this slide, I was using a notebook. But now I'm seeing you using like MySQL Workbench, and I'm like, does like both of them works, or you can just choose any that you wanna use?
Um, Whether you use notebook or workbench, it will work as long as on the notebook. I know the one thing that people are having problems with it is connection. But once you connect everything and everything is set up well, then all the queries you're writing here, you can write them there and then they will just work. I just don't have notebook installed in this computer, so that's why I'm using Workbench.
Okay, thank you.
All right, so we performed the first join. I believe you guys have seen what we have done with the first join. Now, the second part is now to join the water source table, right? So we've joined location and visits table. So the next thing we want is to also now join the water source table. Now to join the water source table, of course, uh, these first columns here are from the first join that you have done. That is this table up here: province name, town name, visit count, and location ID. So we are getting type of water source and number of people served. I believe this is from the water source table. Let's just confirm the water source table. Water source. Yeah, so we have type of water source and number of people served. So what we are going to do, let me just see, type of water source, number of people served. So we're just going to add them here because we don't want to write another query. So maybe we can say w dot type of water source type of water source. And then the other one was number of people served. So W dot number of people served, number of people served. So we have that, and then because this is the first join on that, and then here we're going to add another join. So we're going to say join. So we're joining water source as W, right? Because remember we're using W as an alias. So water source as W. On So here we're using source ID, right? We're using source ID. So we're going to say uh, b dot source ID equals to w dot source ID. That, then we run these, and then we also have these. So now we have all the columns that they need us to have. Yeah, so now we have all the columns here. We have province name, town name, visit count, location ID, uh, type of water source, and number of people served. Okay, so you have done these first parts. Note that there are rows where visit count is greater than 1. Okay, these were the sites our surveyors collected additional information for, but they happened at same source stroke location. So for example, add these to your query. So let's add these and see what they are trying to talk about. So let's add it. Okay, I think there's an error. Oh, a non-column visits dot location ID. So okay, we were using v. So here we'll say v dot location ID. It's supposed to be ID. Yeah. So we have these where location visit count. Okay, let's see what they're saying. So this is what I got. I think this is the same thing you've gotten. So there you can see what I mean. For one location, there are multiple uh, that records for the same location. If we aggregate, we will include these rows, so our results will be incorrect. So basically what they mean is you can see we queried with the same location ID, right? So with this same location ID, you can see, look at the visit counts. We have somewhere it was recorded as 1, some were recorded as 2, 3, like that, like that. So basically, this is one location, but you can see there is some sort of inconsistency or redundancy, right? So that's why they're saying if we continue like this, our results will be incorrect. So to fix this, we can just select rows where visit count is equal to 1. So we remove where visit.location ID is equals to that and add visit.visit count equals to 1 as a filter. So this one we are replacing with where v.visit count v.visit count equals 1, like this, so that we can have the correct thing here. So all these visit counts are 1. Okay, now that we have verified that the table is joined correctly, we can remove the location ID and the visit count columns. So we need to remove the location ID and visit count columns. location ID and visit count. So let's get rid of these two columns. Yeah. Okay, so we've done that. Then add the location type column from location and time in queue from visits to our result set. So after removing those two columns, we need to add a location type. I can see we have location type just after type of water source and then time in queue. Okay, so let's add those. Let's say location type and time in queue. Location type and time in queue. So location type is from the locations table. So L dot location type, and then okay, I'm seeing some error. Okay, time in queue, time in queue. Oh, okay. So location type, we have urban and we have rural. We also have time in queue included. Yeah, so we have all that included. Last one, now we need to grab the results from the well pollution table. This one is a bit trickier. The well pollution table contained one data for well. If we just use join, we will do an inner join so that only records that are in well pollution and visits will be joined. We have to use left join to join the results from the well pollution table for well sources and will be null for all of the rest. Play around with the different join operations to make sure you understand why we used left join. Here is the code. So water source dot town name province name. So this is the same code that we have written, except that now for well pollution, you can see they're using a left join. They're joining well pollution using a left join instead of inner join or the normal join. This is the same query. They've only added this. The rest is the same as our query. The only difference is that here there is no aliasing, right? So I think we can just let's replace this with our query. And then maybe some formatting so that it can look readable. From visits. Let me do some formatting. Yeah, yeah. So you can see results. Some we have now, then others we have the results that we want. This is the effect of using left join. Okay. So this table contains the data we need for this analysis. Now we want to analyze the data in the result set. We can either create a CTE, that is common table expression, and then query it, or in my case, I'll make it a view so it is easy to share with you. I'll call it the combined analysis table. So you can decide to create a CTE or you can create a view. Now, I think this will depend on with your situation. If you want persistence, then it will be good to go with a view because views basically, um, when you create a view, it will stay within your database unless you delete it. If you create a CTE are session based. So within that particular session, your CTE will exist, but when that session expires, then the CTE will also gets deleted automatically. And session in this case, we're basically referring to this instance where you're using your database or the workbench in this case. So the what we are doing now, this is like a session, all right? So it means when we are done and then I close my workbench, the CTE gets deleted automatically. So that means the end of the session, the CTE also disappears. But for views, they persist. So if you want to review it sometime later, then it will be good to just create a view. So the code has been provided. So basically, it's the same code that we have here. If you want to create a view, we'll just add a line on top here. We'll just say create a view. It's just like when you're creating a table or when you're creating a database, you use create and then whatever you're creating and then you provide the name. So in this case, okay, what was the name? Or combined analysis table. Combined analysis table, and then you have to include this. So let's run this query. So after running the query, let's confirm if our view is created. So we refresh, and then you come to views. So you have the combined analysis table. You remember, I think it was last week, but one we created this view here, incorrect records. So you can see this is still here. Even though I closed down this workbench and I've reopened it today, but the view is still there. But now if you try to query the CTEs that we created last time, they don't exist, right? So this combined analysis table is also another view that we have created with all those columns. So views are just like tables. So this view creates a table that pulls all of the important information from different tables into one. So we gathered the information that we want to analyze from different tables, and then we brought them into one table. So we create that table as a view. You may notice our query is starting to slow down because it involves a lot of steps and run, blah, blah, blah. So I think that one you can analyze on your own. So basically, we are done with joining the pieces together. So the section of joining the pieces together basically involved gathering the data we want to perform analysis on from different tables. We bring them together into one table, and then now we can perform analysis rather than having to query a lot of tables each and every time. Actually, they have talked about time here. So if you have to fetch data from different tables all the time, it takes time. But if you create a view like this, it will be easier to query, and then you don't have to write a lot of complex queries that consume a lot of resources. So the third section is basically the analysis. So we are building another pivot table. This time we want to break down our data into provinces or towns and source types. If we understand where the problems are and we need to improve at those locations, we can make an informed decision on where to send our repair teams. I believe you understand what pivot tables are from the previous module when you guys were learning about what is it called? Spreadsheets or Excel. Uh, it's easier to create pivot tables with Excel, but for MySQL, it's a bit complicated, but it's possible, right? So what we are interested in here basically is to break down data into provinces, towns, and source types. So the provinces, the towns, and then the types of water sources. All right. We want to perform our analysis based on those three main things. Okay. So let's continue. We did most of this before, so I'll give you the queries I used, explain them a bit, and then we look at the results. So, okay, queries will be provided. The queries I'm sharing with you today are not formatted well because I'm trying to fit them into my chat messages. Okay. Oh, okay, let's just continue. But make sure you add comments and document your code well so you can use it. So this is the first query that has been provided. Some few comments here and there. So basically, I think we need to be able to understand what these queries are doing, so that when they talk about analysis, we understand what is being analyzed. Okay, so with province total, so this is a CTE, this is a common table expression. So what this is doing is to calculate the population for each and every province. You can see he's selecting province name, and then he's summing the number of people served, right, from our view. Okay, remember our view had the province name and the likes. So basically, it's trying to get the population per province. You can also see here as grouped by province name. So after getting the population for each province, I can see this one here is a case where source type is river, people served is that one times 100%. So is in this second part basically is trying to calculate the percentage of people who are served per water source, right? So he's using a case. I believe you guys learned about control structures. You can use if. You also have case in this particular situation. So we have the first case here where the water source is a river. So if the water source is a river, then you take people served times 100%, and then you divide by total population. The total population, total people served as river. So remember, have the total people served or total population from this CTE here. So you'll get the percentage of people who are using a river, and then you get the percentage of people who are using share taps, and then you have tap in home broken, and also wells. So this one covers all the water sources, all the types of water sources that we have in this case. So from combined analysis table, which is our view, and then you can see he has provided an alias because it's kind of stressful trying to type all these things uh, all the time. So you give it an alias. So when you're giving an alias, you can either use the keyword as. So you can say combined analysis table as CT, or you just leave it blank. If you don't use the as keyword, then you just provide the alias, and then join province total on province name equals to province name, and then it's grouping by province name, and then ordering by province name. So basically, this first code that has been provided here, this code helps us to calculate percentage of people who are using each type of water source per province, right? So for instance, if you take a province like Akatsi, you know that it has rivers, it has shear taps, tap in home broken, and well. So out of all these, what percentage of people in Akatsi are using a river? What percentage are using shear taps? What percentage are using a well? Like that, like that. So that is what this query is doing for us. So I think let's copy it, let's run it, and then we see. So let me do some cleaning. I'm removing the comments so that it can be readable at least. So that's the city there, and then we also have now the main query, which gives us the percentages that we want. Okay, formatting these is yeah, I think this is now a bit readable. So let's run it. No output, then error somewhere. Unknown column, people served. Let me rename the columns properly. When we created the city, the view here, number of people served, as people served, as people served, and then what was another problem? Source type, source type, source type. Type of water source, source type. Let's delete this view and then we should be able to create it. Drop view. Then let's create it. Source type, people served. Okay, now that's good. So after that, now we need to run these. Okay, we're running. Okay, good. So I had to rename some columns there. I think these columns like uh, type of water source. So we needed to rename them to source type so that okay, to reduce on the time for running typing all those things. But now here is what we get. You can see we have different water sources per province, and then the percentage of people who are using these different types of water sources in each and every province. So for instance, the first one here is Akasi. You can see 5% of people are using river, 49% are using share tap, and 14% of the population have taps in home. And then you have 10% having taps in home broken, and then 23% are wells. and so on and so forth on each and every province. Okay, so after that, let's continue. So province totals is a CTE that calculates the sum of all people surveyed grouped by province. If you replace the query above with this one, select all from province totals, you should get a table of province names and summed up populations for each province. So if we select these province totals, province totals, so let's replace it with this. Yeah, you can see we have the total population or total number of people served per province. So we have Sokoto is I think this is 5,774,434. So we have the populations like that. So I think that is okay. You can continue. So you should get a table of province name and summed up population for each province. That is correct. The main query selects the province name, and then, like we did last time, we create a bunch of columns for each type of water source with case statements, sum each of them together, and calculate percentages. So this is explaining the CTE and how we came up with the percentages. So we join the province totals table to our combined analysis table so that the correct value of each province total population, total people served value is used. Finally, we group by province name to get the provincial percentages. So this is just a description of how this guy was able to, combine different queries and tables to come up with the percentages of number of people served per province per water source, right? Run the query to see if you can spot any of the following patterns. Look at the river column. Sokoto has the largest population of people drinking river water. Okay. I think it's good if we read and then confirm. Okay. Oh, it's taking a long. So they're saying Sokoto has the highest number of people. Oh, wait. Sokoto has the highest number of people who are drinking from a river. Now, look at the column for river. This is a percentage of number of people who are getting their water from rivers on each and every province. And you can see Sokoto down here has the highest, 21%, while others are at 8, 4, 3, and 5%. Sokoto has 21%. So what that means is these people, their main source of water, or compared to other provinces, is a river. So that means if those rivers have any issues, then they need to be mended as fast as possible because it actually helps a lot of people from this province. Meaning if you wanted to fix a river, then the first place you want to fix is Sokoto because it's where we have the highest percentage of people who are collecting water from the river. Okay, so that's what he's saying here that we should send our drilling equipment to Sokoto first so people can drink safe filtered water from our well. So you want to go and fix the situation. When it comes to fixing sources that are river, then Sokoto will be the first place. Probably you don't want people to be drinking water from river because rivers can be easily get contaminated. So you'd rather drill for them wells. So that's why they're suggesting you take the drilling equipment to Sokoto so that wells can be drilled there. Another thing is majority of water from Amanzi comes from taps. but half of these home taps don't work because the infrastructure is broken. So we need to send out engineering teams to look at the infrastructure in Amanzi first. Fixing a large pump, treatment plant, or reservoir means that thousands of people will have running water. This means they will also not have to queue for water. So we improve two things at once. So Amanzi has the highest people are using taps, and also let's see Amanzi. So this is Amanzi. You can see tapping homes 28%, the highest, right? The highest. And then if you look at tapping home broken, this means these are homes that have the systems, the water systems installed within homes, but they are not functional. Okay. Also, Amanzi is leading with that 24% compared to others that are 10, 15, 12, and 10. Okay. So if you wanted to fix taps that are broken in homes, you'll need to go to Amanzi first because that's the highest population of people who have broken taps. Okay. Another thing he has mentioned is when you fix taps in homes, you're not only fixing taps in homes, but also you are reducing the queue. Remember, people are queuing in wells where we have a well. So a well is like a public or in shared taps, right? But a tap in home, that is a tap that is in somebody's home. You will not need to queue for you to fetch water from a tap that is installed in your home. Okay, so that is how you are fixing that issue. Okay, let's continue. So I made another graph to help us see the patterns. Okay, so this guy went ahead and of course created a graph. You cannot create graphs uh, on Workbench, but I think if you're using a notebook, then you should be able to create a graph. But of course, you need a bit of Python. But generally, creating this kind of graphs or this kind of graphs is going to be your next module where you'll be learning about visualizations. So you'll be using Power BI to create these fancy graphs and do a lot of things. Okay, so this is just a visual representation of what we have just seen from the query that was provided, which was showing us the water sources per province with the percentage of people that each and every source is having. Okay, so this is a graphical way of representing it. So you can see each and every province. For instance, we have Amanzi, and then we have tapping home. Uh, okay, I'm stupid with colors. I don't know if this is red or orange. So tapping homes is the orange, and then I think this is the yellow, which is tapping home. So the orange one is tapping home broken. The yellow one is tapping home. I don't know what this color is. That is tap nearby. And then there's a black one here, which is tap far. You have bio.ul and all that. So let's aggregate the data per town now. You might think this is simple, but one little town makes this hard. So, okay, what we have right now is data that has been aggregated per province. Okay, it's per province. You can see from the table that is generated here. But now here, we also want to aggregate the data per town. But then he's saying one little town makes this hard. Recall that there are two towns in Maji Ndogo called Harare. One is in Akatsi and one is in Kilimani. So we have two towns that have the same name, but they are in different provinces. Okay. Amina is another example. So when we just aggregate by town, SQL doesn't distinguish between the different Hararis, so it combines their results. I think that is self-explanatory. We have two towns, they have the same name, but they are in different provinces. But remember, we want to aggregate our data per town. So what SQL will do is it will combine the data for these two Hararis as one. Okay, so that means if we want to separate these two towns, we have to also not only grouped by town name, but also by province name. Okay. To get around that, we have to group by province first, yes, and then by town, so that the duplicate towns are distinct because they are different, because they are, I think here is supposed to be they are in different provinces. Yes, but basically that's what I've just said. We need to group also by province so that we separate these two towns. Oh, okay. Query again has been provided. So this is again a query. We have a city here that selects province name, town name, some number of people served as that from combined analysis, group by province first and then town name. So what this CTE is doing, just like the previous query, the CTE was calculating total population per province. Now this one is calculating total population per town, right? This is calculating total population per town. And then these towns are grouped based on the provinces they are in. So basically it means we can start with Akatsi as is a province. And then we are going to list all the towns in Akatsi with their total populations. Okay. Then after that, this is the same query like the previous one, but now we are getting the percentage of people that are being served by each water source per town. Okay, so let's copy these and we go and format it. Let's remove these comments. So we select province name, town name, and then number of people served. Let's move the comment, join, town name on that. Let's remove these comments, group by that, and that, order by town name. So let's run these. Good. So we have this one now. So you can see we have the province name, we have town name, and then we have the percentages. So for instance, we have Abidjan. Of course, he has ordered them. You can see order by city.town name. So that's why you can see the towns are grouped by province, yes, but the ordering is by town name. Okay. So when you order by town name, basically it's going to order the town names alphabetically. So it starts with Abidjan, Amara. You can see this is letter A, then we go to B, C, D, up to the last alphabet. Okay. So you can see Abidjan, for instance, in this case, we have 2% of the total population of Abidjan using rivers, their water source. 53% share tap, 22 tap in home, 19 tap in home broken, and 4% is well. So we have all these like this. And by the way, look at this column that is highlighted. You can see the province name is Akatsi. The town name is Harare. And then just below it, we also have the province name Kilimani. then the town is Harare. You can see these two Harares are now separated based on where they are located, based on the provinces they are in. Okay, all right. So here the city calculates town totals, which returns three columns: province name, town name, total people that are served. In the main query, we select the province name and town name, and then calculate the percentage of people using each source type using the case statements, just like we did with the provinces. Then we join town totals to combine analysis, but this time the town names are not unique. So we have to join town totals, but we check that both the province name and town name matches the values in combined table analysis. Then you group by province, then town name. So this query can take a while to calculate, so hopefully you start to see how query can quickly become slow as it becomes more complex. I think you noticed this with the one for provinces and now this one for town names. It takes time because the query is complex. Before we jump into data, let's do it as temporary table first so it is quicker to access. Temporary tables in SQL are a nice way to store the results in a complex query. We run the query once and the results are stored as a table. The catch, if you close the database connection, it deletes the table. So you have to run it again each time you start working in MySQL. The benefit is that you can use the table to do more calculations without running the whole query each time. So to do that, you basically add this at the start of your query. So this is again how you create a temporary table. Now, temporary table again is different from view or CTE. Okay, this is going to create a table, yes, but that table, because it's temporary, it's not even going to appear among the tables that are within our database. Okay, it's just a table that is temporary that's there. It's session based again, just like what is it called? Like a CTE. So let's put this on top here. So that one will create a temporary table. So this is the syntax: create temporary table, and then you provide the table name. Okay. So the reason why we are doing this, the reason why we are putting this as a temporary table is because you have noticed how long it takes to run this query. It takes quite some time. So you can imagine if you'll be, you'll be using this table in the future more often, then it means you'll have to run this query continuously each and every time you basically want to use it or you want to retrieve something. So instead of doing that, and it consumes a lot of time, you can create a temporary table for this so that instead of writing all this complicated code, which is complex and makes it takes a lot of time, you just query the temporary table that you have created, right? Um, let's continue. So this is the table that we just gotten there. So let's order the results set by each column. If we order river in descending, it confirms that what we saw on a provincial level. People are drinking river water in Sokoto. Okay. So basically, if you try to order it, so if you order for instance, if you order the river column in descending order, you'll see that, uh, remember from the previous analysis, we realized that in Sokoto has the biggest percentage of people getting their water from river compared to other provinces. And if you order this, it's supposed to reflect that you're going to see uh, the top percentages from towns that are in Sokoto. So actually, let's try and see. Um, Okay. Um, so this is the query. You can see I've just selected the columns from the temporary table that we have created, and you can see it gives me this data. So to order these columns, you can just click on the column name. You can see if you click, it reorders them. So this has reordered them from in ascending order. If you click again, it orders them in descending order. Now you can see this actually confirms it. So look at the province name. So all these towns in Sokoto are the highest. So basically it still confirms that in Sokoto, highest percentage of people are getting their water from a river. But look at the tap in home percentage in Sokoto too. Some of our citizens are forced to drink and save water from a river, while a lot of people have running water in their homes in Sokoto. Large disparities in water access like this often show that the wealth distribution in Sokoto is very unequal. We should mention this in our report. We should also send our drilling teams to Sokoto first to drill some wells for the people who are drinking river water, specifically the rural parts and the city of Bahari. Next up the data by province name. Um, Next, and look at the data for Amina in Manzi. Here, only 3% of Amina citizens have access to running tap water in their homes. More than half of the people in Amina have taps installed in their homes, but they are not working. We should send our teams to go and fix the infrastructure in Amina first. Fixing taps in people's homes means those people don't have to queue for water anymore. So the queues in Amina will also get shorter. Well, you can confirm these. For the purposes of time, I'm not going to confirm everything. There are still many gems hidden in this table. For example, which town has the highest ratio of people who have taps but have no running water? So if you run this, we can see that Amina has infrastructure installed, but almost none of it is working. And only the capital city, the Habu's water infrastructure works. Strangely enough, all of the politicians of the past government lived in that, so they made sure they had water. Okay, I've forgotten what they were talking about here. So Mina's infrastructure installed, but almost none of it is working, and only the capital city, the Habu's water infrastructure works. So, so Amina, you can see Amina here, percentage of broken taps, you can see it's 95%. Okay, so that's why they're saying it has taps, but biggest percentage of the taps are broken. But then if you look at the hub where he's saying most of the politicians were leaving, only 2% of the taps are broken. So it means majority, bigger percentage of taps in the hub are actually working. Okay, so I think that is good. It would be so nice to see this data, but because there are so many sources and so many towns, it's hard to explain this visually without some better tools. Imagine if you could have a graph where we do this kind of filtering and sorting of data in the graph. Okay. So basically, we are moving to the next section, which is summary report. But from the previous two sections, that is joining pieces and the last analysis, you can see and understand what we have done. We were interested in trying to understand the provinces, towns, and water sources, right? But then to do this, we don't get all this information by querying all the tables. Yes, you have to query all the tables, but it's tedious to kind of query all the tables that have the data we need. So basically what we have done is we pick what we are interested in, and then we combine them into one table, the view that we created, and then from there we perform analysis. We have managed to get percentage of population that are using each and every water source per province and then also per town. Okay. So basically from that analysis, you should be able to generate a summary report. Okay. So we have insights here. So a couple of weeks ago, we found some interesting insights. So most water sources are in rural. Yeah, 43% of people are using shared taps, 2,000 people. So these are previous, I think these ones you guys can read. 45% face non-functional systems due to issues with pipes, pumps, and reservoirs. Towns like Amina, the rural parts of Umanzi, and a couple of towns across Akatsi and Awasa have broken infrastructure. Yeah. So I believe these ones you can read. Then, you can also confirm from your analysis of the past, or from the analysis you did in the past and what we have done today. So plan of action. So we want to focus our efforts on improving the water sources that affect the most people. Most people will benefit if we improve the shared taps first. So of course, people will benefit if shared taps are improved first because you're going to reduce on the queues, how long it takes for people to queue, right? Wells are a good source of water, but many are contaminated. Fixing this will benefit a lot of people. Yeah, that's true. Fixing existing infrastructure will help many people. If they have running water again, they won't have to queue, thereby shortening queue times for others. So you can solve two problems at once. Also, installing taps in home will stretch our resources too thin. So for now, if the queue times are low, we want to improve that source. So basically, to improve the sources, you're starting with sources that have high queue time. If the queue time is high, it means that source is serving a lot of people, right? And if it's serving a lot of people, that is why for an individual to get water from that source, it takes a longer time. If you compute that, you realize that a lot of people are actually being affected, and therefore, what's affecting most people is what you need to fix first, right? Most water sources are in rural areas, so we need to ensure our teams know this, as this means they will have to make these repairs, stock upgrades in rural areas where road conditions, supplies, and labor are harder challenges to overcome. So, practical solution. If communities are using rivers, we will dispatch trucks to those regions to provide water temporarily in the short term, while we send out crews to drill for wells, providing a more permanent solution. Sokoto is the first province we will target. I think you can tell from the analysis we've done why Sokoto will be the first target. So for communities that are using rivers, we're going to drill wells, okay? Because the rivers are easily contaminated. They are open water sources, open. So basically, a bird can die and they just falls into a river. You know, river water is easily contaminated. So that's why they are suggesting to drill wells. If communities are using wells, you install filters to purify the water. So for chemically polluted wells, you can install uh, reverse osmosis filters, RO filters, okay? And for wells with biological contamination, we can install UV filters that kill microorganisms. But we should install RO filters too. In the long term, we must figure out why these sources are polluted. So for wells, we know that wells pollution might probably occur from chemicals or biological contaminants. So for chemicals, we install RO filters, biological, we install UV filters. And then for short taps, in the short term, we can send additional water tankers for the busiest taps on the busiest days. We can use the queue time pivot table we made to send tankers at the busiest times. Meanwhile, we can start the work on installing extra taps where they are needed. Okay. According to UN standard, the maximum acceptable wait time for water is 30 minutes. With this in mind, our aim is to install taps to get queue time below 30 minutes. So towns like Belo, and that have a lot of people using share taps. So we will send out teams to those towns first. So for share taps, you want to install more taps so that people don't have to queue in just one tap or two or three. Install as many as possible up to a level where queue time for individual is less than 30 minutes. So shut up with the short queue times represent a logistical challenge to further reduce waiting times. Addressing broken infrastructure offers a significant impact even with just a single intervention. It's expensive to fix, but so many people can benefit by repairing one facility. So fixing a reservoir pipe that multiple taps are connected to. We identify towns like Amina, Lusaka, and all that. Seems to be good places to start. So our final goal is to implement our plan in the database. We have a plan to improve water access in Maji Ndogo, so we need to think it through. And as our final task, create a table where our teams have the information they need to fix, upgrade and repair water sources. They will need the addresses of the places they should visit. So they'll need the addresses, street address, town, province, and the type of water source they should improve and what should be done to improve it. We should also make space for them in the database to update us on their progress. You need to know if the repair is complete and the date is completed and the date it was completed and give them space to upgrade the sources. Let's call this project progress. Okay. This query creates the project progress table. So we have create table, project progress, ID, source ID, address, street, town, improvement, source status. So this is a query that you can use to create that table they're talking about, which is called the project progress. Okay. Here is a less commented one, so it is easier to see how we design the project progress table. So we have the project ID, the source ID, which is the ID of the source that is supposed to be improved, address, town, province, source type, and then the improvement. So improvement is basically like what improvement has been made in that particular table. Then you have source status. So default is backlog, that means nothing has been done. And then we can also have in progress, meaning they are in the process of continuing the work, and then complete is the work has been done. And then we have comments here. So comments is what the engineers will be saying after they have done the work. Okay. So run this query, and then we are going to build the query we need to add the data in there. At a high level, the improvements are as follows. A river is to drill wells. Wells, if the well is contaminated with chemicals, then we install RO filter. If well, and then wells, if the well is contaminated with biological contaminants, we install UV and RO filter. For share taps, we want to reduce the queue time. So if queue time is longer than 30 minutes, we install a certain number of taps. Okay, nearby where X is the number of taps is calculated using using flow time in queue divided by 30. Then tap in home broken, we diagnose local infrastructure. So we should be thinking case functions. Let's take the various improvements one by one and then combine them. Okay. So to make this simpler, we can start with this query. So select location.address, town name, that from water source. Left join well on that equals to well pollution, like that, like that. So this joins location, visits, and well pollution tables to water source table. Since well pollution only has data for wells, we have to join those records to the water source table with a left join, and we use visits to link various IDs together. Okay, so first thing first, let's filter the data to only contain sources we want to improve. To only contain sources we want to improve by thinking through the logic first. Only records with visit count equals to 1 are allowed. Any of the following rows can be included where shut-up have queue times over 30 minutes. Only wells that are contaminated are allowed. So we exclude wells that are clean. Include any river and tap in home broken sources. So basically what this means is the improvements that are supposed to be made. So we want to make improvements on records with visit count equals to 1. Okay. So if visit count is equals to 1, that's the first thing we need to check. And then we also need to check if the share tab has a queue time of over 30 minutes, because some part up there they said according to UN laws, queue time should not be greater than 30 minutes. So we are going to improve share tabs where queue time is greater than 30 minutes because we want to reduce it to be less than 30 minutes. And then for wells, we are looking for contaminated wells only. Okay, so if our well is clean, there's no need of improving it. And then for rivers, we also need to include river and uh, tapping on broken sources. So we also need to include rivers and also broken taps. Those are the things we need to fix. So there's what is this thing called? Um, I'm forgetting the name. Oh my God. Okay, it's not coming. Yeah, flow diagram of how, at least when you're writing the logic. So of course they said you want to look for sources where visit count is 1. Now, if where well pollution records the pollution of wells, and here they said only wells that are contaminated. So if well pollution is clean, then there's no need of improving it. Okay. Sources, river or tap broken. So we also are going to fix rivers or broken taps. And then if a source is shared tap and then the queue time is greater than 30 minutes or equals to 30 minutes, then we are going to fix that. And then we have the cases here. Soil pollution is equals to chemical, then we are going to install RO filters. If well pollution is biological, we are going to install UV and RO filters. If the source is a river, then the improvement we are going to make is to drill a well. If source is shear taps, then we are going to install a certain number of taps. Okay. And then if source is tap broken, then we are going to diagnose the infrastructure. So I split up the logic into the where and case clauses. When this makes the logic more complex to follow, my thinking is to remove all the data we don't need first, like record with visit counts greater than 1, and then do calculations. So let's start with where. So basically it means there's supposed to be a query up here where visit.visit count is 1. This must always be true. And one of the following or options must be true as well. So contamination, uh, well is not equals to clean, or it's either tap in home, or I believe it's supposed to be river because they said here, where is that? Yeah, source is river or tap broken. So tap in unbroken or river, or we also have some code you're supposed to insert here equals to share tab and something. So fill in the blank end and add it to project progress query. So you should get something like this. Okay. So okay. Some people might be feeling lost, but basically, what we want to write here is we want to write a query that is supposed to create a table, this project progress table. Okay. Okay, so here, yeah, said, okay, we created the table, but it does not have everything that we need, right? It does not have all the data that we need. So what we want to do is we want to write a query that is going to contain, we can call it, let's say we call it project progress query, that table. So in this table, we want it to have the address, the town name, the province, the type of water source that is supposed to be improved, the improvement that is supposed to be done, and all those other things, right? And then within this table, we also need to include a column called improvements. So improvement is basically where we are going to record the type of improvement that is supposed to be done on each and every water source. Another thing, we're not doing improvements on all okay, we are doing improvements on all water sources, but let's take an example. If a well, because in the wells, in the what was it called? In the water source table, yeah, water source. We have type of water source, and then we have well pollution table. There's a table called well pollution. Yeah, well pollution table here. So well pollution contain pollutions that are in different wells. Now, we have a column here called results. So result records um, if a if a water source, if a well source is polluted by maybe um, chemical pollution or it's not polluted. So if it's not polluted, it's recorded as clean. So that means that water source is clean. We don't need to do improvement on it. Okay, we don't need to install the RO filters and the UV filters, right? So basically, this query that you're going to write, we have to also keep in mind that for sources that don't need improvement, we're not going to include them in the query. We are not going to need to improve them. What is already working should not be interfered with in short. Okay. So all that this person has been describing up to this point is the things, the constraints that we're supposed to keep in mind while writing this query, and basically all the other rules that we're supposed to follow. So step one, let's start with wells. Depending on whether they are chemically contaminated or biologically contaminated, will decide on the intervention. Okay, so from what I've read here, I think the first thing we need is we are going to need an address, right? Address is in the locations table. Let me just confirm. Location. Yeah, we have address. Because we need address of each and every water source we are going to improve, right? So address, we are going to pick that. And then we also want town name. Town name is also in the locations table, as well as the uh, do we need province name? I don't think we need province name. But anyways, we can include, so we have town name. And then since we have the source ID, the address of a water source, we also need the ID, source ID. Source ID, I think, was in water source table. Yeah, source ID is in the water source table. Okay. And then we also need the type of water source, which is also in the type of water source table, is also in the water source table. Which type of water source is it? Your water source is this. Okay. And then from the well pollution, we're going to need results. The result column was that well pollution. We are going to need results column. Why do you need results column? Because we're going to use that column to see which wells will need improvements and which ones will not need improvements. Okay, and then we are going to use case to for purposes of filtration. For purposes of filtration. So let's just read through and then write the query. So let's start with wells. Depending on whether they are chemically contaminated or biologically contaminated, will decide on the intervention. So use some flow logic to create, install UV filter or install flow filter values in the improvement column. Okay, improvement column. That is the column that will be in our table. Remember, I've told you there will be an improvement column. So if you did that, there should be install arrow filter in that one, values in the improvement columns now, and lots of null values. And then for rivers, we upgrade those by draining new wells. So add drill well to the improvement column for all river sources. So it means for river sources, what we are going to do in the improvement column is to add the drill well. Okay, remember if people are using a river as water source, we said river can be easily contaminated. Okay, so the option is to drill for those people aware. Okay, so check your record to make sure drill well for river sources. Okay, and then for share tabs, next share tabs, we need to install one tab near each share tab for every 30 minutes of queue time. So here we can use a logic, a case. So case something, okay, when type of water source is something and something, then this is what we are going to do. So we are going to concatenate. So this is basically the concat here. This is what is going to be in the improvements column. Okay. So it means in the improvements column, we're going to say install certain number of tabs nearby. Okay. Flow. Remember they said install X number of tabs. So we are going to compute, we are going to calculate those X number of tabs. And they said the way to calculate that X number of tabs is to take time in queue divide by 30. Okay. Time in queue divide by 30. So if time in queue is 300 minutes, remember we want it to be less than 30 minutes. So you're going to divide it by 30 minutes to identify how many tabs to be installed. Okay. So he's using floor because he wants to round the calculation down. Okay, you cannot have 10.5 tabs. And then home tabs. Let's look at in home tabs, specifically broken ones. These tabs indicate broken infrastructure. So this needs to be inspected by the engineers. So here again he's recommending that we add a case statement to our query, updating broken tabs to diagnose local infrastructure. So our first query should now return that one, blah, blah, blah. And then add the data to project progress table. Okay. Now that we have the data we want to provide to engineers, populate the project progress table with the result of our query. Hint, make sure the columns in the query line up with the columns in the project area. If you make any mistake, just use drop table, that one, and run your query again. Okay. So I believe I have gathered enough information to be able to do that. So let's keep this code here. So what I want to do is, of course, I'm going to delete this table because this table that we've created is empty. But let me write the query first. So you're going to say create table, and then the table name is project progress. Project progress. Okay. Now we want to create this table from already existing data. Okay. Here they have just provided us these things, but where do we get the address? Where do we get the town? Where do we get the province? Well, province is also there actually. So all these we are getting them from other tables. Okay. So what we are going to do here first is create table. Our table is going to be called project progress, right? And then select. So we want address, all right? Address is in the, I think it was in the locations table. Yes. So select, okay, let me use aliases l dot address. And then you want to name it address, capital address. So that's the first column. Then we want town. Town is also in the locations table. So l dot town name as town. Okay. And then we also want province. So l dot province name as province. And then we want source type. So source type is in the source type water source. So I think for water source, let's use w dot type of water source as source type, right? So that is source type. Then improvement, I think we are going to create it dynamically. And source status. I think another thing I can add here is we have results. This one, I'll have to create a code to create it because I can't just add improvement here now. So that I think we can also add results. So wp.result, that is well pollution.results, because I think we also need that. and we forgot source ID here also. So w.source ID plus source ID. Okay, let's continue. We will correct the rest baadaye. So here we want to use case. Case. I think we can start with which one can we start with? The first one was the first one here is wells. So let's start with wells, okay? So let's start with wells. So they say that for wells, if it's contaminated biological, then we are going to install RO filters and UV filters. If it's contaminated chemical, we're going to install just RO filters. Okay. So well pollution. Yes, so this is well pollution. I want to see the results column. Yes, so this is how the results column looks like. So we have the contamination type. So contaminated biological, and then we also have contaminated chemical, and then we also have clean. So what I'm going to do here, I'm going to say, oops. So I'm going to say, so our first case here is when WP dot results, yeah, results. When WP dot results is equals to contaminated biological, like that, we're going to say then here we need to install arrow filter. So we'll say install arrow filters. Okay, that's the first case. And then the second case, we're going to say, so if it's biological, we're going to install arrow filters alone. But if it's chemical, no. If it's biological, we are supposed to install arrow filters and UV filters. So maybe you can say this is chemical. And then the next case is WP dot results is contaminated biological. Then we are going to install arrow filters and UV filters. I believe that's what they said. Install arrow filters and install UV filters and arrow filters. The next one is rivers. So now for rivers, we update those by drilling new wells. Add drill well for improvements column for all river sources. So for river sources, we need to drill wells. So case. So we can say when type of water source. So when W dot type of water source is river. So if the water source is river, then we'll say drill wells. like that. And there's something they also mentioned here about river. Okay, so next one is share tabs. So share tabs, we need to install one tab for each share tab for every 30 minutes of queue time. So case is going to be case. Actually, I've been doing a mistake here. Case is supposed to be, yeah, case like that, and then we have the different cases. Now, so for share tab, okay, let me just confirm. So, so when the type of water source, so I think the first blank here we are going to say when the type of water source is uh, is share tab, and then queue time you are going to say, and also time in queue is greater than 30 minutes, then you're going to perform this calculation here. Okay, so that's the next thing you're going to do. So you're going to say when w dot I think type of water source, yeah, w. Okay, good. So in w dot type of water source is shut up, and time in queue was in the visit table, I believe. Yeah, time in queue. You can say v dot time in queue is greater than or equals to 30, then we're going to use that method for concatenation. So concat install flow tabs nearby. So concat, then you're going to say install flow tabs nearby, like that. So I think it makes sense like this. Does it normally have commas? Oh yeah, the commas are there. So like this. Now this flow here, basically what we are doing here, we are taking v dot time in queue, and then we divide by that to calculate how many tabs are supposed to be installed around that one particular tab. So for example, what this means is basically, if you go to a tab and you find that queue time is maybe 60, and you want to reduce it so that the queue time is less than 30. So you're going to take that 60, which is the total queue time, divide by 30, meaning each and every tab is supposed to serve a person for 30 minutes. Okay. So if you divide it, you're going to realize that you're going to need two tabs so that each and every person can take water there for only 2 minutes. And then the last thing is taps in home broken. So taps in home broken. So they said so this needs to be inspected by our engineers. Add a case statement to our query updating broken tabs to diagnose local infrastructure. So this is supposed to be to Diagnose local infrastructure. So final query that and no null values. So we're going to say when type of water source equals to tapping home broken. Then we're going to say diagnose local infrastructure. I think you can add here else now. Then let's end our case, and then all this is supposed to be recorded in the improvements column. Okay, as improvements. Should we have a comma here? Oh, good. Okay, so those are the columns that you need. Mhm. Okay, let me finish this query first. So this is supposed to be from water source as W. We're using water source as W, and then they mentioned about left join. So left join. So we're joining water source to well pollution. Well pollution as water like that. Mm, then I think we're supposed to perform another left join. Hmm, left join on w.source id equals wp.source id. Okay, good. And then was the other one in a join? Mm, yeah, left join well pollution on that. Yeah, in a join visits table. So in a join visits table, and then we also in a join locations table. Okay. So this is inner join. Inner join visits as V source ID society, and then again inner join the other location. Yeah, we inner join location as L on location ID equal to location ID. Then they mentioned something about visit count. That was the first thing here. If you look at our flow diagram here, so visit count is one. So here we can see where v dot visit count. Visit count I think is in the visits table, right? Yeah, visit count. Visit count is 1, and then the next thing, the next logic. So visit count is 1. Well, pollution is not equal to clean, because if it's clean, there's no need of improvement. So, and well, pollution is not equal to clean. And then, so well, pollution is not equal to clean, and then type of water source. I think I can say type of water source in river and tap in home broken. So yeah, after this, you can say or type of water source in river and uh, taps in home broken, or type of water source is shared tap. And then timing queue should be greater than 30 minutes. Okay, I think this flow diagram is actually helpful, by the way. So where visit count is equals to 1, all right, and um okay, what was that next thing? Forgotten already. Oh, well, pollution should not be equal to clean, because we want to improve those that are not clean. So you can say here and WP dot results is not equal to clean, or and the next one, yes, or W dot type of water source in. So type of water source is either tapping unbroken or river, or um, so that home broken is tapping home or river, or water source with share tap. So share tap, and that share tap has time in queue greater than that. So I think this one should put in brackets, so you can say or w dot type of water source is share tap, and v dot time in queue greater than or equals 30. I'm not seeing any errors so far. So, okay, I understand we also need to incorporate columns like comments, date of completion, source status, but I'm not going to include those ones for now. Those ones we can include later. So let me delete this table so that you can create it afresh. But of course, you will be able to, when you're creating yours, make sure you incorporate these other remaining columns. So let's run this query and see. Mm, unknown column WP, is it result or results? Results. Results. Where did I write results? This is results. Mm, results. Mm, running. Okay, so let's refresh this. And then we have the project progress table. Okay, so this is what we get. Now you can see we have this new table called project progress. So it doesn't have all the columns that it's supposed to, because we also need to have comments. We also need to have date of completion, source status, and all that. But from here you can see these are columns that of course we picked from the other tables that we already have. So if we look at source type, for example, we have well. In this case, this well is biologically contaminated. Okay, why is it now? Probably some improvements of my query needs to be done. If we go to the next one here, you can see contamination is chemical. So chemical is supposed to install RO filters. And then for, okay, why are biological empty? Okay, probably I'll need to check on that and find a way to optimize the query. I'm seeing biologicals are null. But okay, you can see this is the same thing you're supposed to get, but now you also need to include the other columns that I have not included. If we go to share tabs, you can see, for example, let's look at the improvement here, the improvement that is supposed to be done. So for instance, this first tab, we're supposed to install 8 tabs nearby. You can see. So this is what we did. So basically, it took the time in queue, it divided it by 30 to get the number of tabs that is supposed to be installed in this particular source. Okay. So this source with this ID is supposed to install 8 tabs. This one 3, 7, 13, like that, like that. So that is share tabs. Let's look at another one. Okay. Well, there seems to be a lot of wells that needs to be improved. Wow. Okay. So this is how you're supposed to do it. Of course, my query, I don't think it's that perfect, but for you when you're writing, probably you can find ways of improvising and improving your query. And then you also need to incorporate columns like comments, date of completion, source status, uh, project ID. So project ID, I think you can auto-generate it. So you can see serial primary key, this auto-generates it, and then it will be unique. Source ID, I think we've included address, town, province, source type, improvement, and then source status. Also, we need to you will include source status in your query, and it's supposed to have a default of backlog. So backlog means no work has been done. Okay, so when some work is being done already, then they will update it to in progress, and then when the work is completed, they will update it to completed for a particular source, and then they will need to record date of completion, and then they will also provide a comment. So these are the columns I think you can include. So after selecting these, you can include your columns as well there, and all the rest. So this query, I think it's a bit complex, and basically this guy started explaining it from here. Okay, so you need to be able to read and understand. So this query that has been provided here for us is basically just trying to, he has created an empty table in this case. Okay, but this table is just like the structure of how the table you're going to create now with the real data should look like. Okay, it should have a project ID, it should have a source ID, address, town, province, source type, improvement that is supposed to be done, source status, date of completion, and comments. Okay, and then these are the constraints, the things that you're supposed to fulfill, what your table is supposed to have. So if the type of source that is supposed to be improved is a river, so where we have a type of water source as a river, you're supposed to drill wells. Okay, and then if the type of water source is a well, there are two things you're supposed to check. First, check at the pollution. What type of pollutants are in there in the well? Okay, if it's chemical pollutants, then you're going to, the improvement is to install RO filters. If it's biological contaminants, install UV and RO filters. If a water source is shared tap, then we need to know how many taps are supposed to be installed around that particular tap. Okay, if it's a tap of ID 200, take the queue time for that particular tap of ID 200, divide by 30, and then create a string that reads install and then the number that you calculated taps nearby. Okay, if it's a tap in home, taps in home first of all needs to be diagnosed. So for a tap in home that is broken, improvement is to diagnose local infrastructure. All right, that's the first thing. And then here, basically, what he's saying is when you're creating this table, he has said we can start with this query. So you can see from our code, this is actually the first query we started with, right? Uh, that's the first query we started with. You can see select, and then you're selecting address, town name, province, type of water source, ID, and all that. Okay. So basically, this is what you are starting with. These are columns that you're selecting from already existing tables, but you want them to be part of your new table. Okay. And then the type of joins you're supposed to have. Now I see why some of the columns were null, because I can see a left join here. It didn't cross my mind. So this is the how your query should look like. Okay. And then now for columns that need computations, you're going to insert them here. So for example, after this last query, well pollution dot results, this is what was we also had WP dot results, comma, and then now we incorporate our cases. So the case section here, this section for case is going, we are using it to create the improvements column. And why are we using case? Because we have different things we have to evaluate, the constraints that I was talking about. The first one was we are checking the type of pollutants for a well. If it's chemical, then install RO filters. If it's biological, install both RO filters and UV filters. Okay. So, and then if the source is a river, of course we're supposed to drill wells. If it's shear tap and queue time is greater than 30 minutes, we're supposed to have this string install a certain number of uh, taps nearby. So this case is what we're using to fill in the improvements column, right? And then this is just the rest of that query that has been provided. Um, this is the rest of the query. You can see it here, right? And then here again, the things you're supposed to fulfill. Visit count is supposed to be 1. Taps are supposed to be greater than 30. And then for wells, they have to be contaminated wells only. If a well is clean, there's no need of improvement. Okay, that is what we have captured here. you can see we are saying if the result is contaminated and then the type of contaminant. There's nothing here that says, well, if the repeat dot result equals to clean, okay, because we are not interested in clean wells, okay. So, and then for rivers and tap in home brokens also. And then they have provided a flow diagram on basically how you are supposed to write your logic, okay. So these are the cases you're supposed to fulfill, okay. These are the cases, and then these are the constraints. So visit count has to be 1. Pollution, well, pollution has to be not equal to clean, okay. If it's clean, then we don't want to do anything with it, okay. So this is not equal to clean, and then source has to be river or tap broken, and then shared taps. If it's a shared tap and queue time is greater than or equals to 30, then of course we will include it in our results set, okay. Then these are now just sections of like is trying to give you like clues within your case statement. How is it supposed to be and all that? So we have these, and then now the chronological order of how you're supposed to write the queries. We have this is another section of a case, okay. So that's why you can see case, and then we have these dots. So there's some queries you've written, and then when this, then you do the rest. Okay, that's the end of this.